Yeah. Okay, folks, we're going to go ahead and get started. Very pleased tonight to bring two speakers who I have a lot of interest in hearing, so very happy about that. My name is Dave Nielsen. I'm the co-organizer, I guess primary organizer of this meetup, and I'm just going to keep it short and then we'll get right into our talks. But before we get going, I'd like to ask a few questions. First of all, how many of you are actually working in ops today of some sort? How many of you are working primarily in dev? A couple of you, okay. A couple hands went up twice, which makes sense. And how many of you are using containers in some way or shape or fashion already? Okay, cool. How many of you are actually using them in production? All right, cool. Glad to see those hands go up. Let's see. If you haven't already, we do have a Wi-Fi. If you want to use it. Oh, did that go by on purpose? Okay. There you go. Is it on a timer? Don't do that to me. Okay. All right, so that's the Wi-Fi code right there. So write that down or memorize it because we're going to move on in a minute. And while we're on this topic, I just want to thank our sponsors tonight, of course, Intel for providing us the venue, and tonight's food and drink sponsor was Joyent and their Trenton platform, so we'll hear more about that, I'm sure. And last but not least, we do have another meetup coming up. See if I put the information up here somewhere. There we go. Oh, how does it do that? Okay. So, this has not gone up on the meetup page yet, but it will shortly. DevOps for Big Data, deploying Spark. There's a lot of interest in Spark, of course. It's extremely popular sort of data platform, OS, whatever you want to call it, compatible with the Hadoop ecosystem. And if you're not familiar with why Spark is popular, it's because it basically does everything in memory. So once you load your data in and you can do all your machine learning and deep learning and all that with in memory. It makes it much faster. And so deploying Spark is pretty challenging if you're trying to do it in containers. And there's a project that's led by Anirudh Ramanathan of Google to make some modifications to Spark to make it so you can actually deploy it effectively in Kubernetes. And then coincidentally, we have in town visiting from London, Brian Borham from Weaveworks, and he's spent a lot of time with networking Kubernetes. So put those two things together and it should be an interesting evening. So hopefully we'll see you there. And finally, just a shout out to the project I'm working on. You probably don't care a whole lot, but in case you do, if you're interested in deep learning in Spark, specifically deep learning and specifically in Spark, then you have to check out BigDL because it is a deep learning framework with all of the deep learning libraries built natively for Spark so that you can have all of your data running in a Hadoop system or in Spark, and you can just leave it there and do your deep learning within Spark. And this is an Intel project. It's open source. It's free. There's no cost. There never will be any cost. You just got to have Spark. Okay, so that's it. Going back. All right, so we're going to have two talks tonight. Our first speaker is Tobias Kunze. He's with a new startup called Glasnostic. And I've known Tobias for a long time. Did you know?
First Cloud DevOps meeting.
Yeah, Cloud Camp.
Yeah.
Did you know it was 9 years ago Saturday?
Oh, really? No, I didn't.
Yeah, 9 years ago Saturday. Popped up on my calendar. I was like, hey, that's pretty cool.
Happy anniversary.
Yay. We're going to have to do something next year.
10 years.
10
yeah.
years.
Wow.
Yeah. Cloud Camp was this thing. It still kind of happens sometimes, but it was a unconference around cloud computing back when cloud computing was like super cool and edgy and new, and nobody really knew if it was a fad or a real thing. And so we had a whole bunch of community focused conferences where we all kind of prognosticated. I mean,
Pontificated.
yeah, pontificated. Lots of pontification around what's going to happen in the cloud. Back when like Sun actually had containers, and we just didn't give them much credit.
The Sun Cloud.
Yeah, the Sun Cloud.
Yeah.
There was a Sun Cloud. Can you believe that?
Yeah.
Yeah. What was it called? It was.
It was called the Sun Cloud.
No, but I think it was like was it? Oh, and before that there was network.sun.com.
Network.com. Yeah.
Network.com. That's what it was. Yeah. I'm sure you don't give a crap about any of this stuff. But so anyway, it's been fun to watch all of this, and Tobias was there in the beginning. He was the co-founder of a company. Do you remember the first name of your company?
It was OSS-1701.
That's right. and
It
I
was
think
open source, enterprise open source.
That's right. But I think you came up with that because I forced you guys into it because you sponsored that cloud camp.
Yes.
Do you remember that?
Yeah.
We
We
needed
had to get a name.
And I'm like, you can't sponsor if you don't have a name. So they came up with that name, and then that ended up getting a real name, which was called Makara, and then eventually Makara was acquired by Red Hat, and is now OpenShift. So he's a co-founder of what is now OpenShift, and I've been watching you talk about things in meetups all these years since then, since you left Red Hat. Have you gone? Did you have any big project between then and now?
No.
So this is
This is yeah.
all of the knowledge that you've built up
Yeah.
since
Yeah.
and during the OpenShift era.
Exactly.
Oh wow, this is, you don't know what a treat you are in for. This is amazing. Okay, now also in parallel, I was also talking with the Joint folks about doing a meetup, and when they mentioned that Casey wanted to speak about app-centric, micro orchestration, I'm like, okay, I don't really know what Tobias is going to talk about, but I think those things are somehow similar and related. So I'm gonna put them together because that seems like a lot of fun. I haven't seen Casey speak before, but he comes highly recommended. Is there anything we should tell these folks about you to kind of whet their appetite? What's something you've done recently, or even 10 years ago, but super cool?
Wow, I mean, just about me. I'm colorblind, so.
Are you really?
Yeah, I mean, so
For real?
Truly, true stories.
So you've got like, was it 3 cones? 2 cones? How many cones you got?
I'm sure it's more than 3, but
I don't know how many there are.
I cannot distinguish between colors.
Wow.
What have I done recently? I've been at Joint. I should.
How long have you been at Joint?
Don't let me bogart your.
No, this is just all fun. How long have you been at Joint?
I joined about 2.5 years ago.
Oh, okay.
Yeah.
It's a long time to be at a company these days.
Yeah. It hasn't felt like it. It hasn't felt like it, but
Yeah.
yeah.
All right, well, I've been up here a long time, so I'm going to get off. Tobias, come on up and let's get you going.
Sure.
In Casey, you'll be up in about, 20 minutes or so? Half an hour?
Yeah,
I would say?
very, very
Okay.
fast.
All right, here, you can switch over to your,
Uh-huh.
I come up with it. Sorry about There's your thing when you're
I
ready.
need to log in first.
Okay. All right. And if you stick around, my friends at Redis Labs gave me an extra large t-shirt. So somebody's going to be super lucky. You can get an extra large Redis Labs t-shirt.
Is it gonna come up?
Oh, it should. You know what? There you go.
It didn't.
Is that it?
Yeah, I need to just replay because.
Okay.
Okay. Let me go.
And just
back.
speak up
So,
because
yeah. Okay. So Dave mentioned everything, so we can make this really fast. My background is in tech, really. I've had a bunch of like dev and ops before there was DevOps. So both sides kind of like positions at different companies. Most notably, then I did run development and operations for the shopping arm of Lycos when there was still Lycos in Europe. Which was interesting, not because it was Lycos, but because it was like large-scale LAMP deployments, if you remember that, and also LAMP-J, so with Java, Tomcats. And due to that experience and the specific pains, as Dave mentioned, went on to start a company that was a PaaS for the enterprise. So think of it as a Heroku behind the firewall, right? So if you needed you were an enterprise, you had a JBoss, blah, 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 on patch level, whatever, running somewhere certified, you could get this with us. You couldn't get this anywhere else. That eventually, that was a full-on PaaS guy. That eventually was acquired by Red Hat, and as David mentioned, turned into OpenShift, which is the same thing as Cloud Foundry in green. And then I started kind of like losing the excitement for PaaS. I don't know how many people here have run on some kind of PaaS. Can it? Oh, one, two,
I have.
two. Wow. Okay. So slowly realized for myself, it's not a great opinion, but it's a personal opinion that the PaaS really to beat is AWS. Right? A bunch of Legos that you get to run your applications. I've always been clearly interested in how do you run applications and how do applications look like, right? And that was also a good experience because I spent a couple years, it takes a long time, on the Oasis Tosca standard as a technical representative for Red Hat. That was a largely IBM-driven, who's heard of Tosca? Wow, okay, okay. So topology and orchestration specification for cloud applications, that's what it stands for. Essentially, how do I get my really complex SAP or whatever else application installation fitted on any cloud infrastructure, right? So essentially you're writing a recipe, a specification, and then a cloud should run it. And that was a really weird and strange experience because at that time, we've been seeing the rise of services, right? This is like, a lot of companies did this. The microservices started, right? You would start breaking up things. And the interesting thing is here, even in, between 2014 and 16, Uber exploded to like now north of 2,000 services, logical services, not just instances. And Yodel was acquired now, but it's still a similar curve. The thing is, you saw this exponential curve, right, in services. So what happened is that more and more things got broken up into services. And so that's how it kind of looks like. Those are famous pictures like called Death Star diagrams, right? Because you can't operate this, right? The interesting thing here, what I would like to point out is not just that it's like thousands or whatever deployments and services. The interesting thing is that where is the application? Does anybody see an application? Not really, right? Because what happens is, and everybody thinks is in the belly of the beast, in the belly of the enterprise, you have some smart applications that provide great products, great customer experiences, right? But that's not how it works. Because if you look in the belly of the beast, you get to see something like this, which is a really messy, I don't even know what to call it, layers and layers of existing applications, existing services that are all getting connected, more and more being deployed constantly by different groups, different maturities, different life cycles, right? Kind of like you see a movement going to like exploratory workloads, to chasing new opportunities and all that. So, and at some point that stops because you're hitting whatever number it is that your organization can run and in different services. Because somebody comes up and I have this great idea, here's a service, it's going to talk to 20 of our existing services already. Can you please run it? And what do you say? No, because I have no idea what it does. So that develops into a huge roadblock to innovation, essentially. Because as an enterprise, you want to keep innovating, keep putting new things in there. As we all know, coding is really simple today, right? I mean, on a certain level, it's really simple, right? Running it is simple. Any cloudy infrastructure, right? Any whatever container even, right? You just deploy it as a container and it runs. The problem is ops has no way to knowing what it does, right? Even if you say, well, I'm only going to talk to these 50 services, you may issue requests and then they fan out. The ripple effects, systemic failures, these kind of things. So nobody can deal with that, and that's why they need to say no. They need to stop. So what we are doing to end this whole story, what we are doing is we move everything into real time. The idea is if you're running something really complicated, let's say a Broadway musical, you're this guy here, and you have a big honking console in front of you that does two things. It gives you very rudimentary but critical visibility, and it gives you very few knobs that you can tweak where you know what they're going to do. So you have a playbook of operational patterns that you can apply. Like, a light goes out, a microphone blows up. You dial it down, you ramp another one up, right? Key here is that nobody tests the lights or QAs the lights beforehand in 6 weeks, or creates a staging environment to test what they're going to do, right? So that's the idea. Here again, like what we believe needs to be done in real time is you do not monitor nodes at all, because if you care about what your disk I/O is, you shouldn't be running 50 plus services. You can't operate this. You need to get visibility into if something goes wrong, where you can look, because then there's tons of tools that you have that you can hook up to your Hadoop cluster, to your storage cluster, to your J2E application or whatever you're running over there, right? First you need to see where to look. So we're only looking at interactions, only at segments, right? The communication between nodes is where it's really at. And then, very critically, only a very small amount of metrics. Everybody in the industry that does monitoring goes down the path, more data is better, which means just you just won't be able to see it, right? So we have a very small set of 4 metrics: requests, how many, how long do they take, latency, how many pile up, because that's important, because that might be an indication how many workers ultimately or threads are being tied up, and bandwidth, right, for noise neighbor problems. That is kind of like what we see as a blood test, as a blood panel for a certain service interaction. If something is off there, you know something is not quite right, either with services that are talking to it or services that are being talked to. And then once you've discovered where things are not quite right, you can apply a number of things that you know will work. You can ring fence it, you can quarantine it, right? You can insist on a network segmentation. You can insert a bulkhead. You can have a circuit breaker defined in runtime on that segment, right? So both things, right? Visibility that's really actionable, and then a playbook that you can apply for control. That's nothing new. People have done this for a long time. This is I love this picture because it's the main panel on the Oak Ridge National Laboratory reactor, where the interesting thing is the red line up there at 4200, and this little thing here where somebody posted a scram at 4200. Right? If it hits this number, scram. do not stay here, right? That's essentially what we're doing, what we're applying to communication links. That's how the product looks like. We have 3 modes, which we call define, explore, and monitor. And what it really is, in define mode, you're looking at your entire infrastructure, at your entire application assembly. And you say, well, I know that these things here are critical, so I want to have a ring fence created here, defined, so that later on, should something happen, I have the control already. All I have to do is do this here. In our mixing board analogy, that would be, I'm getting all my microphones in these two channels already, right? In case something happens, I can control them, right? Then, because we obviously never know everything beforehand, there's an explore mode, where as it's running, you can slice and dice the data. You can explore where things are going on, or not quite according to expectation. That's the middle panel here, and I'm going to demo this in a sec. And then there's a monitor mode, which is really just where you are as an operator, like the air traffic controller. Each thing is a ticket that you've done, that you're observing currently. Clearly, the goal is to have as few tickets as possible, right? But you can see, was it fixed? Is it still occurring? And so forth, right? So very simple. And with that, let me switch over to the demo. I need to pull it up. So starting out in define, this is it's probably a little small. Let me just zoom in a little bit here. You see a visualization of a large-scale installation is an e-commerce application above, and boxes below where you can define segments that you want to look at, and your metrics that you're looking at, up here. Right now we're looking at requests, right? And you can see there's, like, for instance, let me zoom in here. There's an orders service, there's a purchase database, there's a view history. So it's a bunch of microservices, and it's all being captured in real time, what happens here. And critically, you can click on any of these things, and you see who's talking to it, and who is it talking to, right? And those red lines here are the hot segments, hot communication segments. And we also have yellow lines that are also hot, but not quite as hot. And the gray ones are kind of like the normal ones, normal links, right? So you want to be focusing on the red interactions. Those are in terms of numbers of requests, right? If I go to latency, as could be expected, a lot of these database links here that are down there are, take more time than others, right? But let's drill down a little bit on, let's say, where was it here? Let me switch to that. Here, this load balancer. It's being talked to by all these services here. Let's say I want to see who is talking to it. So I'm just using this as a service endpoint, and it zooms in into these services. I can see who is talking to it. I can look, let me flip the perspective around. So now, this is my load balancer here, and this is where the traffic's coming from. So let me select all the product things here. So now I focused in on a set of segments, right? And what I can do now is, examine what's going on there. And this is like in the past 5 minutes, that many requests in aggregate, that's latency, that's the concurrency, and so forth. Very little bandwidth all of a sudden here, like a bunch of requests here, very little bandwidth. What does this tell me? Probably not right? Probably a lot of requests are being denied. So something I may want to look at, so I could say here, well, this is like all, the product services need to talk to the product team. What's going on here? Product team. So I'm creating a ticket, right? As soon as I do that, everything is automatically channeled through this box, which gives me, it wraps a control box around these segments, which I can now use to throttle, to inject policies for that, right? For instance, if the team comes back to me and, oh yeah, we're getting all these things because requests are being denied, need to be like, those requests need to be like stretched out a little bit, then I can go in here and say, okay, let's throttle our requests down to, let's try it out. Let's start with 200,000. Now from now on, everything that goes through this control box is throttled. Remember the scram at 4200, right? And once I've done that, I can continue to do other things. I can look at my monitor list, and I see here is the channel that I just created, this control box. that captures this set of network segments, right? And so forth. Now I talk to Pete, not Pete, to the product team here, and then let's assume it works again. I just cancel this as a ticket. It's done, right? That's real-time management of communication interactions, right? The same thing in the other mode is it's similar, right? Now I'm slicing and dicing. I see all the channels that I have created. On the inner ring, I see all the nodes that act as clients, and on the green side, I see all the services that act as services. And I can select any of those, right? Let's say, let's just look at how the log database is doing. I have a bunch in, right now there's like 3 running, and I've selected this part of the overall architecture, right? And you know, I can see like we have 4 services hitting like 3 different databases right now. I can switch this around to get a different view, the perspective from the log database. And same thing again, I can decide, oh, is there something I want to capture for later, so I can go back to it. I can star it, I can give it a name, right? And continue to slice and dice. Now this is bundled, a new control box is created around it, right? So, and just so it displays better, is I can give it a better name than this here. The auto-generated one, test box. Yeah? Right. Now, it's a logical definition of that. See, better names. And I can see how does this correlate with in latency. It shows it doesn't really register. It's those small dark spikes here, right? Those lines, those segments. On the concurrency side, it's log messages. A lot of these pile up, but it's kind of to be expected. And bandwidth also, like 1/3 of my traffic in the data center is going to log messages, right? Those are like top level metrics and bits of information that I need to make sure everything is managed to the customer experience. The key takeaway here is really that these services that are running, the nodes that are running, literally change by the minute, or if you're slow by the hour, right? Some department in the enterprise is going to deploy a new service every hour, so there's no blueprint, right? You need to go back and look at it in real time, and in real time you need the right amount of visibility and the right amount of controls. And with that, I think we can go to the summary, which is, as I just said,
Go ahead.
we are about viewing, seeing things, and being able to do things. We look at traffic exclusively, not at systems. So if you care about how many sockets are in close wait, you're doing something totally different, right? And then those 2 components, visibility, you need to get the key data, not a fire hose of data, like most other monitoring systems give you, so that you can get actionable insights, not just some random data. And then on the control side, you need to have in mind a set of operational patterns. If something happens, I can apply this playbook, right? This playbook, so that the remediation that you do is predictable. That's it.
Okay.
I think 20 minutes.
And I've got a question for you.
Yeah.
So you, I think you did a nice job of differentiating between monitoring the pods and monitoring the communications.
Mm-hmm.
And then at the end there you say control operational patterns and then predictable, what was it? Predictable
Remediation, control, yeah.
What does remediation look like? Like in this world? And is it something that you think should be part of your platform, or, you know, part of Glasnostic, or is it something that somebody else is going to be providing the solution for?
Remediation is part of this platform. And this is like first line of defense, right? Because what I'm discovering here is, remember we were looking at log databases. We see a bunch of spikes. Every time I see a spike like this here, 18 million requests a second across all these things, it's going to cause trouble. Even if not a single service falls over right now, it's going to cause trouble. So why shouldn't I, you know, impose a limit of 500,000 here, sorry, 5 million, so that from now on, there's a limit, people are going to get slowed down. The system creates back pressure against anybody who's creating too many logs. This guy will be slowed down a tad, but the overall system continues to work. It's not going to cause a second or third degree further systemic failure down the line. Yeah?
And
So
that
that's the
happens
control
at-
aspect.
And that happens at the, sorry if I missed this earlier, but what is actually going to slow that down? Is it like the network nodes? Like where does that
Oh,
get slowed down?
technically, we are in the network.
Okay,
So everything goes through us,
got it,
right? If you wanted to.
right,
That allows you, as like in a mixing console, right? We are very basic. It's a mixing board. But we can't mix if it doesn't go through us.
right.
Right? So it goes through us, and that allows us to inject policy.
So are you actually in the network?
We're in the network.
Like
yeah.
the nodes? Like is this sort of like a, what are they calling these things nowadays? Like, you know, Linux networking system or something like that?
We are, okay, technically.
Yeah, technically.
Technically, we are a layer 3 traffic shaping system,
Okay.
traffic management system,
Okay,
except we only care about layer 7 metrics.
okay,
Yeah?
yeah.
That said, we do not do deep package inspection or anything like that, right?
What's the name of that open source project that does like traffic shaping?
There are many.
I know it's just one of those very simple ones from a long time ago.
Traffic shaper?
We used it at the Cloud Center for DevOps days. I can't remember what it was. Robert Harker helped us set it up. Anyway,
there are firewalls that do that.
It was a
that you
simple
can
one.
use, but
it was just simple. Anyway, okay.
Yeah.
So you're actually slowing things down at the network level in order to keep systems from getting overloaded.
yes.
Yeah. Okay.
But from a service perspective, so not from the network perspective, right?
Right. Right. You're keeping an eye
Yeah.
on the services,
So
but then
all
slowing
these
things down
packets
at the
of
network.
flying by,
Yeah.
we know, oh, this here is part of this network segment that we, this communication segment that
Yeah.
we just wrapped this notional box around, right? Now I need to make sure those rules are being applied.
So in the overall stack of technologies that one would buy, you're not actually getting involved in any deployment.
No, no.
Wow. Okay.
We're zero install.
Yeah.
It's just we act as a gateway in the network.
Yeah. Yeah.
So
Yeah.
like a big black hole, we suck it all up, and then you can turn us off.
Right. That's wild. Okay. Cool.
Yeah.
Neat
So
idea.
no installs, no agents, no nothing. Yeah. Because you can't install agents, right? I mean, people have all kinds of things running.
Yeah.
Yeah. Nobody is only deployed on Kubernetes or only on Cloud Foundry or whatever, right?
It's like a ghost.
It's just a network device,
Right.
if you will.
Okay. Yeah.
It's like fuse for the network.
Right. Right. Okay.
Yeah. Any other questions? Yeah.
What kind of policy could you set? It's just rate shaping?
So we can only, right now, only limits on requests, latency, concurrency, or bandwidth. Yeah? But we can do this independently, right? We can, I'm just making up stuff now, but let's say this year was like 200, let's also set a 200 millisecond limit on latency. Now this is in effect a circuit breaker that I just created, right? I say anybody who's talking to these things will automatically circuit break. circuit break. Yeah. So I don't have to deploy Azul or Hystrix or whatever, right? It's just in the system. And if I notice that, hey, it doesn't really do anything, actually this limit is being hit right now, right? It's being hit as we speak. So whereas the other one is not being hit, right? So it may make sense in very noisy log environments. We're still looking at the log DBs here. That certain segments say, I don't want to see every single message. I can sample it. So let's just circuit break them. If it takes too many, if it takes too long to write, just carry on. Yeah. So those 4 metrics.
And how do you initialize the system? Like you have a bunch of nodes or links. So how does it?
It's auto-discovered. So as traffic goes through us, remember we're the black hole, we label the traffic, where it's coming from, where it's going to. And of course it helps if you have a decent naming scheme, right? Otherwise you get IP addresses.
And it means that you have gateways through which the traffic goes?
We act as a gateway to a big network. And we get deployed by you pointing your service discovery to us. So we proxy the service discovery. Now,
So
if
you're
a service
going to
asks,
distribute a bunch of gateways wherever the user wants?
are you asking how we are deployed? Oh, as an AMI, right? That scales out. So on AWS, you would create a scaling group, and yeah, then it just routes through us.
So your entire East West traffic goes to your AMIs, is that?
Yeah, if you, well, to be specific, the services you tell that we are your service discovery, those services are going to go through us. Yeah. If you don't want this anymore, you either tell them to not go to us anymore, or you flip the switch on our machine that just puts everything on pass-through. Yeah. So very easy integration in that way. Yeah. So it's possible to run this for like a couple hours before you go live, if you want to. Right? Ideally, it's intended to be run in production live. Any other questions? Oh,
This may
Casey.
be entirely too specific a question.
Yeah.
What is the method of action when the latency limit is hit? Does it disconnect connections that have been open and waiting for a response for that time, or what happens at that moment?
It's a very good question and very specific. So we start out dropping packets, so they get retransmitted. If that's not enough, we go next step to slow down only those packets, right? Yeah. Reason is that anything that's a little bit more involved gets very resource intensive, and it's more important to us to be available than to be super exact, right? Also, you see the line here of like 120, 200 milliseconds or whatever. If you look closely, those times oscillate a little bit, right? But minimal, like any regulation.
Is this system protocol agnostic?
Yes, it's TCP and UDP actually, so it's IP. Yeah. As I said earlier, we do not do deep packets inspection. In this version, anyways, later version will have an option to do that. But many people these days are certified, and in some form or another, if you run a platform for customers, they may require you to do certification around not inspecting. So by default, we are not.
Okay, we should.
Good.
We should
Yeah, I don't want to
wrap it
take
up.
too much time from Casey. Thanks.
Thank you very much, Tobias. Okay, so next up, I'm going to go ahead and read this because it's well done. So the full title of Casey's talk is going to be App-Centric Micro Orchestration with Turbocharged Docker Compose. Now, earlier I was trying to figure out how to describe Casey, and it turns out the reason why I was having a hard time is because there's a lot of words on here. Casey's a system engineer at Joyent, but he has worked as a system engineer, software engineer, a writer, a librarian, an open source founder, an information architect, and even a director of engineering for GigaOM prior to joining
If
Joyent.
anybody remembers what GigaOM was,
Heck yeah.
before they went anyway.
Yeah, before the poof.
Yeah.
Yeah. And now he's a senior director of product management for Triton, and building the next generation of cloud. So, I don't know, maybe these things have some sort of way of working together someday. And yeah, as it says here, he is colorblind, but he makes up for it with a wardrobe of clashing patterns. You're clashing a little bit, not too much.
Not quite.
Not too much. You got your Triton shirt on, so. All right. Anyway, thank you for coming.
Well, thank you for having me.
You bet. And is it going to set up for you okay?
Yeah, actually, once we got that monitor working, I decided I was going to use it. So there we are.
Awesome.
Yeah. So let me actually hit play on this, and then go grab my remote. So am I talking loud enough? If I speak up a little bit?
I think so.
Fantastic.
Yeah, just remember to speak up.
Yes, absolutely. So yeah, we're here. There's a title I like, and we're going to get into why app-centric micro-orchestration. But there is the marketing people were like, no, we got to anyway. So there's this longer title for the whole thing. We're going to skip past that. But how many people here? I assume everybody here is using containers in some way. Yes, maybe.
For fun or not? Yeah.
All right, so half the people are asleep, but using containers probably. The other half are using containers. How many people have used Docker Compose? Is that a thing? And how many people would actually recommend that anybody else use Docker Compose? It certainly, or how many people are actually using Docker Compose in production? Yeah. Okay, yeah, a couple of like, not really. Somebody's like, don't look at me, I didn't do it. Yeah, actually, so the reason we're going to talk about Docker Compose is that it's actually kind of an interesting thing when you set that as a constraint. When you say, I want to build something really sophisticated, but I'm going to use the world's dumbest and least sophisticated way to deploy the application, and how is it going to work? And there's something magical that happens, and that's why we're talking about app-centric orchestration, because you can't do it from the outside. Docker Compose, it can't do the kind of orchestration that you may be thinking of when we talk about orchestration. And how many people, I'm going to apparently ask questions all night, how many people are like, you know, I know everything about orchestration, I know exactly what it is, I should be up on stage. Is any,
Hey, where is that person?
yeah, actually, I want to know. But the frustration I have with orchestration, and forgive me, I'm going to walk around a lot. So,
I can tell.
The frustration I have with orchestration is it actually means everything. It means all of the things you need to do to operate your application automated. That's what orchestration means, and there is no limit to that surface area. So, it gets kind of interesting. What I want to do is actually find a way to limit that surface area a little bit, focus on the applications, and that's what I mean. But hey, I'm Casey Bison, and I'm here from Joyent. You may know that we were recently acquired by Samsung. In fact, it was, thinking of anniversaries, it was a year and a week or so ago that we were acquired. And if you're using the newest Samsung phones, that means you're also using Joyent. So I'm really excited about that.
Cool.
Because hey, they were a customer. Does anybody remember the ads? Yeah, hands up. Yeah, I will ask questions all night. Thank you for the shaver ads. I liked the company so much I bought anyway. That was a long time. That dates me. But I see from the beards around the room and other indicators that I'm not alone, perhaps. Anyway, I'm going to skip most of the marketing slides, but I will say Joyent is hiring, so please talk with me afterwards if that's a question. Hiring all sorts of positions. And I want to talk, I got to go back and look at my slides. I actually wanted to maybe jump into a demo because we can do this with slides, but who wants a demo instead? Yes.
Yes,
So
both.
exactly. So let's see. This is why. Let's see. That fits on screen there, and I've got the wrong thing up. But so what you can see is I've actually deployed something there, which is cool. Let me show you what that is. So let's put that monitor on screen. Bam. So what I've done is I've checked out this repo. It's all open source. The cool thing is it's got a Docker Compose file in it. There are a few people who raised their hands for Docker Compose, so I think you know what it means. The important thing about Docker Compose is it's a way of taking Docker images and using Docker API to programmatically deploy those images in a repeated sort of fashion. So when I define MySQL here, what it means is when I do Docker Compose up -d MySQL, I will deploy that particular service. But I can deploy the whole thing all at once, and there's really only two things in this particular example for now. I can deploy that whole thing by doing Docker Compose up, and it deploys those two services, just one each. And then the next thing I do is a Docker Compose scale, and bam, we've got that scale. And so we've got a database. Yes, you're looking at MySQL. Probably, so MySQL accounts for, I don't know what percentage of database market share. My understanding is that it was 95% of all RDS for quite a while. Anyway, so we've got MySQL running, and we've deployed it in Docker using Compose, Docker containers using Compose. And how many people have tried to deploy databases with Docker before? Is that okay? Okay, yeah, cool.
But I cheated. I deployed Redis.
That's a great start. And you know what? So Redis, I love Redis. There are new databases that understand that they're not going to be running standalone, and then there's MySQL, which is like, oh, wait a minute, you want to run two or more? That's you got a lot of work to do. MySQL, it has warts on it. It's an application where they've documented how to do a bunch of things, but nobody's automated these things. You take Redis, and it's like, oh, you want to run as a cluster? Easy, boom. MySQL, you got to do a little bit more work. So the cool is, let's actually take a look at how this is running. So I'm going to leave those there. Clear. And let's just paste in a Docker exec. And I want to assure you that everything it takes to operate this and add those 2 extra hosts as it's scaled is built in. So the orchestration here, the things, and I think around this room there are a lot of people who understand what it takes to run MySQL. When you bring up new hosts that you want to add as replicas of the primary, you've got to do work to join them to the cluster. But you've actually seen everything I've done to join it to the cluster, and you can see here that those 3 hosts, there's a primary, and then I've got one that is running, there's a primary and then the 2 replicas. And here's the replica status on one of them. We can see that it's connected to a primary. And so we've got these things up and running. And you know, in the earlier talk there was, and Tobias showed some cool stuff that like it looks like magic. To me, this